This is the next installment of videos in a series regarding how to set up the AirLogix centrifugal compressor controller. In this lesson, we will cover two topics: control signal configuration and manual valve control. Pressing the first button, control signal configuration, we have a menu that allows us to configure how the compressor will be started, stopped, loaded, and unloaded. In the first row you can see we can determine if the panel view will perform any or all of these operations. The second option asks if we want to start, stop, load, or unload over communications from a supervisory computer or PLC. And last, we have the option of performing these operations with discrete I/O connected to the AirLogix. At the bottom of this section, we are asked if we want to enable remote control functionality. This might be a little misleading. As you just observed, I enabled some remote control functionality above, by selecting communications operators. When selecting this option, a new menu called Remote Mode appears, with the identical options to the Local Mode menu. But now, when I return to the main screen, you see a new selector called Local Remote. You also now see a tag that tells you you're in Local or Remote Mode. In Local Mode, the settings on the first or top half of this screen apply. And in Remote Mode, the settings in the second or bottom half of this screen will determine how the compressor is operated. And finally, the Enable Remote Setpoint button determines if the compressor controller's pressure setpoint can be changed by the remote device. This would be a typical setup. When in local mode, only the panel view can control the compressor. But in remote mode, only a network device, like a PLC or DCS can. Enabling local remote control functionality adds a level of safety by allowing personnel at the compressor to place the control system in local mode to prevent remote control of the compressor while performing routine maintenance like surge tests, valve calibration, and inlet and oil filter service. Now, let's talk about manual valve control. When you open this screen, the first thing you notice is a trend graph showing system pressure, machine or discharge pressure, motor current, inlet valve position, bypass valve position, and inlet air temperature. The start position, sometimes referred to as the unloaded position, is configured during setup, such that a positive pressure is established at the discharge of the first stage, when running unloaded. And at the bottom of the screen are controls for the valves. Notice that both valves are currently in auto mode. For the purpose of this simulation, we're going to assume the compressor is running, as indicated by motor current. You'll see there is a system pressure reading, but no machine pressure. The inlet valve is currently at 15% open. Just enough to have a positive flow of air through the machine. And the bypass valve is 0% open, thus, the reason for no machine pressure. First, I'll put the inlet valve in manual mode, and then the same for the bypass valve. In manual mode, I can inch either valve, open or closed, in increments of 0.1%. But this is a very slow process. So to get the compressor loaded, I'll click on the valve position value and enter a number. Watch the inlet valve move to 25%, and the motor current increases with it. Now I'll increase to 35%, and again, the motor current increases as well. I can inch the bypass valve closed, or in the same way, enter a value for valve position. Watch as the machine pressure begins to climb as I close the bypass valve. Were the machine to become unstable, I can press the E-open button, which will immediately open the bypass valve. In a future video, we will simulate the throttle surge procedure using this screen. But for now, let's explore the other functions seen here. Using the buttons on the left of the screen, I can move backward and forward in time on the trend. I can also change the minimum and maximum scaling value for the Y-axis. Now, there is one last sub-menu to explore. This button will take us to a new screen that allows us to set up and tune the PID loops. This screen is used to tune the compressor response to various operating conditions. When the compressor is loaded and modulating to meet system demand, the primary goal is to do so with the bypass valve closed. Assuming the bypass valve is closed, the inlet valve will modulate to maintain system pressure. As system pressure rises, the inlet valve modulates closed, and as the system pressure falls, the inlet valve modulates open. As the inlet valve modulates closed, flow through the compressor is reduced, and motor current decreases. When motor current approaches the DTL set point, and gets within the motor current PID offset, or 8 amps in this case, the inlet valve control switches to the DTL PID. This is compressor minimum load. Conversely, as the inlet valve modulates open, flow through the compressor is increased, and motor current increases. If motor current approaches the motor FLA set point, minus the motor current PID offset, inlet valve control switches to the max amp, PID, or compressor maximum load. And the last PID loop is to control the bypass valve to system pressure. This happens anytime the inlet valve is throttled to DTL, and the bypass valve must be modulated to prevent surge, and still maintain system pressure. In this table, you can adjust the gain, reset, and rate for each of the 4 PID loops. When the inlet valve is on the pressure PID, and is approaching either DTL or max amps, the motor current PID offset determines the distance, in terms of motor amps, when the next PID loop takes effect. When the discharge pressure is less than the system pressure, by the amount entered in this field, machine pressure PID offset, the check valve is considered closed. In this case, AirLogix will put the bypass valve in manual mode, in order to be close to loading back into the system rapidly if needed. The last 3 variables pertain to the rate at which the inlet valve ramps up and down, during loading and unloading. Once you press the load or unload button, the pressure PID set point will be increased or decreased by these values, for every unit of time displayed in the last field. In this example, when increasing, the set point for the inlet valve PID will ramp up 1 psi per second, and when decreasing, ramp down in 2 psi increments. That's all for this lesson. Be sure to like this video, and check back for more instructional videos and demonstrations. And thanks for watching.